Hi, this is javinkharod. Today we start our today's topic, Clays process. Now, what is that? Clays process is the most significant gas desulfurizing process, recovering elemented sulfur from gaseous hydrogen sulfide. First patented in 1883 by the chemist Carl Friedrich Claes. Clays process became the industrial standard. Now, multi-step Clay process recovers sulfur from the gaseous hydrogen sulfide found raw natural gas from byproduct gases contain hydrogen sulfide derived from refining crude oil and other industrial process. Byproduct gases mainly originated from the physical and chemical gas treatment unit in refinery, natural gas processing plant and gasification synthesis gas plant. Byproduct gases may also contain hydrogen cyanide, hydrocarbon, sulfur dioxide or ammonia. Now gases with hydrogen sulfide content over 25% suitable recovery of the sulfur in straight through Clays plant in alternate configuration such as split flow, set of feed and air preheating can be used to process feed. Now hydrogen sulfide produced, for example, in hydrodesulfurization refinery naphtha and petroleum oil converted sulfur in Clays plant. The reaction proceeds in two steps. 2 mole of hydrogen sulfide plus 3 mole of oxygen produce 2 mole of sulfur dioxide plus 2 mole of hydrogen oxide. The vast majority of the 64 lakh ton of sulfur produced was the byproduct sulfur from refinery and hydrocarbon processing plant. Sulfur is used for manufacture sulfuric acid, medicine, cosmetic, fertilizer, rubber product, elemented sulfur use, fertilizer and pesticide. Now, catalytic step. The Clays reaction continue catalytic step in activated alumina and titanium oxide and so boost the sulfur yield. More hydrogen sulfide react with the sulfur dioxide formed during combustion in the reaction furnace. In the Clays reaction, the resulted the gaseous elemented sulfur. The reaction 2 mole of hydrogen sulfide plus sulfur dioxide produce 3 mole of sulfur plus 2 mole of hydrogen oxide, where delta H is equal to minus 1165.6 kilojoule mole inverse. Suggested mechanism that S6 and S8 dissolve from catalyst active site with simultaneous formation stable cyclic elemented sulfur. The catalytic recovery of sulfur consists 3 sub-steps: heating, catalytic reaction, cooling plus condensation. 3 steps are normally repeated a maximum 3 times. Incineration of the tail gas treatment unit is at downstream Clays plant and 2 catalytic stages are usually installed. The first process, catalytic stage, gas heating process. It is necessary to prevent sulfur condensation in the catalyst bed which can lead to catalyst fouling. The required bed operating temperature. Individual catalytic stage achieve heating the process gas reheater unit desired operating temperature reach. Hot gas bypass, which involve mixing two process gas stream from the process gas cooler and the by-gas from the first pass base heat boiler. Indirect steam reheater. The gas can also be heated with higher pressure steam in heat exchanger. Gas exchanger, whereby cooled gas from the process gas cooler indirectly heated from the hot gas coming out upstream catalytic reactor gas to gas exchangers. Now direct fired heater. Fired reheater utilizing acid gas and fuel gas which is burned substoichiometrically to avoid oxygen breakthrough which can damage Clays catalyst. The typical recombinant operating temperature, first catalyst stage 315 degrees centigrade to 330 degrees centigrade. Bottom bed temperature. The high temperature first stage also help hydrolyze carbon disulfide and carbon oxide sulfide, which is formed. The furnace could not otherwise converted modifies glass process. Catalytic conversion maximize lowest temperature and care must be taken. Ensure each bed operated above dew point of sulfur. The operating temperature subsequent catalytic stage is typically 240 degree centigrade. For the second stage 200 degree centigrade. Third stage bottom bed temperature. Now clear sulfur recovery process. Sulfur recovery conversion hydrogen sulfide elemented sulfur. Hydrogen sulfide is a byproduct processing natural gas and refining high sulfur crude oil. There are many sulfur recovery technology available in different applications. The most common conversion method used glass process. Approximate 90 to 95% recovered sulfur produced by glass process. The glass process typically recover 95 to 98% of the hydrogen sulfide. Fish stream only glass process will be described here. However, sulfur recovery unit information related all sulfur recovery process are available. In the sulfur condenser, process gas coming catalytic reactor cooled between 150 to 130 degrees centigrade. The condensation heat is used to generate steam at the cell site of the condenser. Before storage, liquid sulfur stream from the process gas cooler, the sulfur condenser from the final sulfur separator, routed the degassing unit where gases primary hydrogen sulfide dissolved sulfur are removed. Tail gas gaseous process still contain combustion component in sulfur compound, hydrogen sulfide, hydrogen carbon monoxide, either one incineration unit or further desulfurized downstream tail gas treatment unit. Now, dew point process, the convectional losses process described is limited to conversion due to the reaction equilibrium reached, like exothermic reaction, greater conversion can be achieved lower temperature. However, mentioned places reactor must be operated above sulfur dew point to avoid liquid sulfur physically deactivating the catalyst. To overcome problem, sub-dew point class reaction are oriented parallel. Operating one spare, one reactor has become saturated, adsorbs sulfur. The process flow is diverted, standby reactor. The reactor is regenerated, sending process gas has been heated 300 to 350 degrees centigrade. Vaporize the sulfur. This stream sand condenser to recover the sulfur. Now, sulfur stockpile. Huge amount elemented sulfur are produced worldwide by the glass process. The process has applied heavy petroleum extracted oil sand deposit. The sulfur accumulates heaviest fraction of the hydrocarbon. Owning high sulfur content, oil sand, stockpile, elemented sulfur, process now exit. Now hydrogen sulfide, cinemoseous sour gas and acid gas. Sour gas is commonly present natural gas and oil formation. At lower concentration, it smells like rotten egg, extremely dangerous. It is heavier than air, impaired ability to smell, detect, increasing concentration, exposure greater than 500 part per billion can be fatal. With respect safety, product specification, it must be removed, natural gas and petroleum product. Now, hydrogen sulfide make another potential valuable product, the sulfur recovery unit. Sulfur recovery unit is based modified glass process, which is the two-step reaction scheme overall. The portion totally hydrogen sulfide burned in the reaction furnace to form sulfur dioxide, then the hydrogen sulfide and sulfur oxide react optimum 2:1 ratio elemented sulfur across class reactor. After each catalytic stage, liquid sulfur recovered, class condenser, the remaining unreacted hydrogen sulfide and sulfur dioxide proceed. Next stage, where equilibrium limited class reaction continue in the presence class catalyst. Now, class sulfur recovery unit technique bring industrialization 100 years ago, which were used recycled sulfur contain hydrogen sulfide gas. The technique is the standard technique for processing sulfur recovery unit system, which increases the crude oil production. Middle ash sulfur recovery unit is the refinery need to carry out high load continuous production. Reliable operation sulfur recovery unit system required important ensure upstream equipment safety running. A lot of sulfur recovery unit equipment has been built overall world, plus pollution material and more critically restricted environmental protection law will be strict and main pollution material processing equipment. All factors request improve skill equipment, design selection, sulfur recovery unit in the refinery. Now, sulfur recovery unit technology process and major equipment. Sulfur recovery unit is responsible converting sulfide into toxic sulfur contain gas produced refinery process into elemental sulfur and removing harmful substance tail gas. We divide technology process sulfur recovery unit into 8 steps. Major equipment used include heat reactor furnace, waste heat boiler, sulfur condenser, catalytic reactor, heat exchanger, and fluid delivery pipe. Now generation and collection. Sulfur steam produced heat reactor where the gas contained hydrogen sulfide is mixing potentially air which is collected desulfurization equipment and acid stripping unit. The cooling down process gas heat reactor cool down 350 degrees centigrade where medium pressure steam is produced. First level condensing process gas waste heat boiler is cooled down further 130 degrees centigrade. Primary stage condenser where sulfur stream condensed and separated flowing the sulfur pool. Second level condensing the process gas from the primary condenser heated 260 to 290 degrees centigrade. Waste heat of the gas and comes into primary reactor where sulfur stream produced by further reaction. Process gas step cool down and second condenser where the sulfur stream cooled and separated flowing into the sulfur pool. Reheat third level condensing the process gas from the second condenser comes second reactor where sulfur stream produced further reaction. It heated 220 to 250 degrees centigrade. Process gas primary reactor. When the process gas comes into third condenser, it cool down 130 degrees centigrade and separate flowing sulfur pool. The recovery ratio up to reach 95%. Now, to increase the recovery rate, order to further increase sulfur conversion ratio, hydrogenation dioxide treatment must be added to tail gas from the classes sulfur recovery unit. This is called tail gas treatment unit. Tail gas from the sulfur recovery unit mixed with the hydrogen. After heated, send hydrogenation reactor where the hydrogen sulfide is formed under the catalyzing reaction. Carbon disulfide can hydrolyze and process gas from the hydrogenation reactor cool down, heat exchange with the water and the absorbed hydrogen sulfide content in the process gas absorbed by the amine and the sand acid gas pipe and the gas from the adsorber contain minor hydrogen sulfide usually lower than 200 part per million which is transformed sulfur dioxide being emitted. Now, the sulfur recovery unit and petroleum refinery designed to move hydrogen sulfide, sour gas originate various refinery process convert them to industrial grade molten sulfur. The process used sulfur recovery in the petroleum oil refiner known gases process, which remove 95 to 99 percentage hydrogen sulfide present in the gas stream to modified gases. Sulfur recovery process 1. Hydrogen sulfide rich sour gas with oxygen cool the burnt gas and the recover molten sulfur from the burnt gas. The sulfur compound present in crude oil are transferred all products fractionated crude oil distillation unit sour crude the sulfur more 0.5% compared to sweet crude in the downstream unit. Sulfur compounds are converted hydrogen sulfide and produce sour gases which are adsorbed amine solution. The hydrogen sulfide petroleum oil refinery, the refinery of gases, LPG separated from the crude distillation unit, the gas concentrated unit, recycled gases, the hydrotreating unit, hydrocracking unit, and the gas stream are treated amine to remove hydrogen sulfide in an amine gas treating unit. Regeneration rich amine produce feed gas. 4. Sulfur recovery unit. Sour water produce hydrotreating, hydrocracking unit. Extract that produce hydrogen sulfide. Ammonia rich gases that also fed the sulfur recovery unit. Okay guys, this is up to our today's topic, gases process. I hope you get sufficient knowledge after watching this video. Next Sunday we have covered some another chemical engineering topics. Till then, goodbye. Do take good care of yourself.